Welcome to Health Science Decoded with your hosts, Dr. Chen and Professor Ling. We all want to live longer, healthier lives, right? But what if we could really, truly extend our lifespan? Not just by a couple of years, but by decades. Today, we're diving into the incredible science and the really profound social questions behind the future of aging.
So let's just jump right in with the big one. Could we live to 150? For centuries, that was pure fantasy, the stuff of myths and legends. But now, with all the advances in biology, this is becoming a serious, tangible scientific question. We really have to ask, are we on the verge of something that will radically change what it means to be human?
And it might not be as crazy as it sounds. Just think about this for a second. In the 20th century alone, all those breakthroughs in medicine and public health gave humanity an average of 30 extra years of life. That is an entire generation added in just 100 years. That's an absolutely incredible leap. But here's the catch. That amazing progress has revealed this fascinating paradox. While our average lifespan shot way up, our maximum lifespan, that absolute upper limit a person can reach, has barely budged at all. It's almost like we're all getting closer and closer to a wall, but nobody can actually break through it. We've hit what some people are calling a longevity glass ceiling. So here's what we're going to cover. We'll look at why that ceiling even exists, we'll dive into the cutting-edge science that's trying to shatter it, and then we're going to zoom out and ask, what would a world where people live well past 100 actually look and feel like? Okay, so first up, the longevity glass ceiling. To really understand it, we have to get our heads around the idea that aging isn't just one single thing. Scientists now think there are two fundamentally different kinds of aging, and this explains why something that works on a mouse just doesn't work for us. See, in animals with short lives, like mice, aging is because of something called dynamic instability. Their biological systems are just kind of fragile and can collapse pretty easily. But human aging, that's a different beast entirely. We experience what's called entropic damage. A better way to think about it is like a slow, steady buildup of tiny errors over decades, where our body's core information literally gets corrupted, and that difference leads to two totally different scientific goals. Level 2 interventions are all about extending our health span, that's the number of years we live in good health, all the way up to our natural limit. This is where most of the research is today. But level 3, that's the moonshot. That's about trying to reverse the aging process itself and blast right through that 150-year barrier. So how in the world could we possibly achieve something like that, a level 3 moonshot? Well, scientists are trying to go straight to the source code of life itself. I'm talking about tools that could let us edit our biology at the most fundamental level. You have probably heard of the most famous one, CRISPR. The easiest way to think about it is as a pair of molecular scissors. It can go into our DNA, find those specific genetic typos that contribute to aging, and just snip them out and fix them. It's like fixing the body's hardware. And then there's our own built-in countdown clock. At the ends of our chromosomes, we have these little protective caps called telomeres. And every time a cell divides, they get a little bit shorter. Telomere therapy is all about rebuilding those caps, essentially trying to add more time back onto each cell's life. But maybe the most mind-bending idea is epigenetic reprogramming. The theory here is that aging isn't actually hardware damage at all, but corrupted software. Our cells basically forget their instructions on how to function properly. This therapy wants to reboot our cells, restoring all that lost information, kind of like restarting your computer to its original factory settings. Now, as you can see, each of these technologies has just incredible potential, but they also come with pretty profound risks. I mean, everything from making edits in the wrong place with CRISPR to potentially activating cancer with the others. The power to rewrite our biology is definitely not something to be taken lightly.
Okay, so that's the far future stuff. But what about right now? Let's talk about the pills and compounds that are already being developed to improve our health span, what you could call the emerging anti-aging pharmacy.
Now, this is so important to understand. Not all of these compounds are created equal. The scientific evidence for them is all over the map. For instance, mTOR inhibitors show really strong results in animals. Senolytics, which clear out these old dysfunctional zombie cells, are starting to show real promise in humans. But NAD+ boosters, which are super popular, actually have the most inconclusive data for real benefits so far. Let's just take a quick look at senolytics as an example. There was this small but really fascinating pilot study that gave a senolytic drug combo to adults who were at risk for Alzheimer's. And what they found was that it was safe, and it actually reduced a key marker of inflammation. And here's the kicker. In some people, that reduction was linked to better cognitive scores. Now, it's a very early signal, but it's a promising one, and it shows you where this research is going. And all of this brings us to a really vital point. The future of longevity isn't going to be about finding one magic pill that works for everybody. It's going to demand a strategy that is deeply personalized, one that combines a whole bunch of approaches that are tailored to your unique biology. This future health plan is going to be truly holistic. It'll start with nutrigenomics. That's basically eating the right foods for your specific genetic makeup. Then you've got precision health, using AI and data from all our wearables to predict and prevent disease before it even starts. And finally, it fully embraces that deep, powerful connection between our minds and our bodies. And let me be clear, this is not just some vague concept. We can now scientifically measure how chronic stress speeds up aging. Really stressful life events can leave literal scars on our epigenome, which is like the instruction manual that tells our genes what to do. This creates something scientists are now calling stress age, which makes taking care of your mental health a core longevity strategy. Okay, so let's just zoom out for a minute. Let's say the science works. A breakthrough happens. The impact would be absolutely staggering. And that forces us to ask some very deep, very difficult questions about what kind of society that would create. The first thing everyone worries about is overpopulation, right? But the data suggests this is actually a huge misconception. The main thing that drives population size isn't how long we live, it's how many kids we have. And with fertility rates falling all over the world, many countries are actually facing the exact opposite problem: population decline. No, the far more pressing question is about fairness. Who gets access to these therapies? Is it just based on who can pay for it, creating a new biological class system of the super rich who live forever? Or do we treat it like a public health right, accessible to everyone, but at an absolutely enormous cost to society? There are just no easy answers here. And this brings us to what might be the single biggest risk of this whole revolution. And it's not that the science fails, it's that the science succeeds in a world that is completely, totally unprepared for it. This is what's called the preparedness gap. Think about it. Our entire society, our pension plans, our careers, our ideas about family, it's all built for an 80-year lifespan. Our social systems are moving at a walking pace. While this science is in a rocket ship, it is fundamentally not ready for a world where a 120-year health span is normal. Ultimately, the science is moving at an incredible speed, and it's constantly asking, can we? But the most important questions for all of us are, should we? And how do we do this right? Because making sure this revolution benefits all of humanity isn't just a scientific challenge. It's a human one, and it's a conversation we all need to start having right now. Thank you for watching. To continue exploring these topics, subscribe to Kaijin Kai Happy Life Longevity. Please like, subscribe, share, and leave a comment. We'll see you next episode.